Centralized, decentralized, and distributed decentralized databases or systems. In this lecture, we'll cover the three main types of databases and what are the main differences between them. Keep in mind, as we stated before, that blockchain is a type of database, and before we get to understanding what blockchain is, it is key that we understand the different types of databases we have out there. So before we get started with the three types of database, it's always nice to have an overview of centralized, decentralized, and distributed databases. The image below shows exactly how these different structures look like. We have the centralized structure or centralized databases where we have one central storage. In B, we can see a decentralized storage where we don't have one central storage, but rather a couple of network participants act as storage points. And lastly, we have distributed decentralized systems or networks or databases. And here you can see each and every single participant is a data storage point. But let's get deeper into these types of databases individually. First, let's start with centralized databases. This is just the basic structure of a central database. And in centralized databases, all records are stored in a single central database. For any transaction to happen through such a network, it has to occur through a central authority. And most of the time, the central authority is usually a third party. Means we really don't need them in that transaction, other than the fact that they are the ones storing all transactional records. Now, let's look at an example to help us understand centralized databases more. One very, very common example that each and every one of us is familiar with is the banking system. A bank is the perfect example of a centralized system. Imagine Alexa would like to send money to Bill. In our current model, if Alexa would like to send money to Bill, she'd have to send this money through the banking system. The bank in such an interaction or such a transaction is the third party, and it's also the central authority that stores all transactional records. It's the one that keeps account numbers, account balances, and records of transactions between Alexa and Bill or any other people. So the bank here owns the central database and is the central authority. And that's the perfect example of a centralized system operating with a centralized database. Now, this is more common than just banking, and it's something we interact with on a day-to-day basis. Internet structures were built under central databases, and whenever you go message someone on Facebook, that's a central database because you're operating this through Facebook, and Facebook owns the database of any sort of this interaction. And a lot of systems operate like that in the current world. Now, let's look at the second type of database, and these are decentralized databases. Now, in decentralized databases, there's no central storage point. Rather, data is stored across different interconnected databases in the system. The greatest value of a decentralized database is it is more reliable. It means it is less likely for such a system to actually fail. Because if one database fails, there's other alternative databases that store exactly the same information. So there's always backups in decentralized systems. One good example of a decentralized system is the BitTorrent network. Now, the BitTorrent protocol allows users within the BitTorrent ecosystem to share data amongst each other without the need of a central server. Now, I know we are all familiar with BitTorrents. That has been the mode of piracy for a lot of people, be it movies or music and the likes. And BitTorrent works with the mere fact that each and every single person is storing a record, or rather, some participants are storing records and other participants in the network are getting copies from other participants. So there's really no central storage, and when you have databases all across the network, it's highly reliable. That's why it was very hard for governments to take down the BitTorrent despite piracy issues, because whenever you shut down one database, there was always other records all across the network, making it very, very hard to take it down. And BitTorrent is one of the good examples of decentralization and decentralized systems that we've been using over time, even before blockchains. So what's the main advantage of decentralization? And it's just stressing on the same point I made earlier. The main advantage of decentralization is reliability. Decentralized systems or databases do not have a single point of failure. Yes, in case one database in the network fails, there's always alternative databases that store the same records. That means you'll always get back any data, records, or information stored in decentralized databases because there's so many backups in that system. And lastly, we have the third type of database that we all need to understand, and these are distributed decentralized systems or databases. These are actually a type of decentralized databases where there's no particular storage points, but information is stored in each and every single node. And node here is participants in the network, and we'll be describing the term node in the next lecture. So each and every single network participant stores a copy of transactional records, a copy of the information or data that's supposed to be kept within the network. This makes it even more reliable than decentralized databases. And distributed decentralized systems form the basis of blockchain technology, and we'll be exploring these further in the next lecture. So that's it on centralization versus decentralization types of database. And just to summarize it all, let's look at the diagram to your left. And the diagram to your left shows all these types of databases grouped from vulnerability all the way till resilience. The most vulnerable are actually centralized systems, where the failure of a single supplier leads to the failure of the entire system. There's only one database. If it fails, the entire system crashes because all transactional records go missing. Then the second one, we have decentralized systems, whereby the failure of one supplier leads to just a localized failure. But failure of all suppliers leads to a system failure. Yes, when one fails, you have backups who store the same information. But if all of them fails, then you have a network failure. Lastly, the least vulnerable, which is the most resilient, these are distributed systems, where each and every single node is a supplier, or rather each and every single node stores a copy of the records, and therefore this means that it's very, very hard for you to lose copies. It's very, very hard for such a system to fail. And that's it on centralization versus decentralization.